today with me is Christoph Strobl. So Christoph is from Austria. And you know, we Germans go to Austria for skiing because we literally have no mountains, and they have pretty damn mountains over there. So it's quite fun for me. And today we're going to talk about reactive data access in particular for data stores. It's MongoDB, Redis, Cassandra, and Couchbase. And to understand better what's the difference between reactive and imperative, I brought Christoph here, so he's helping me and telling me about the differences. And imagine, well, when my application is under heavy duty and it's really stressed, my servers are on fire. And let's compare that to what happens when a house is on fire. See, that over there, that's my server. And nowadays, I want to access data. And how does that really affect how my server behaves? So, Christoph, can you explain to me what really happens when I do traditional imperative data access today?
Yeah, sure. At least I can try to. I mean, this is pretty much the same thing as compared to that image. I mean, it all starts with an urgent need. So in this case, we have a fire, or on the other side, we have a user request coming in, and the user is waiting for data that he wants to see. And we know users are notoriously impatient and move away if we don't deliver them the data they want to see in a fast way. So what we're doing today, actually, with the imperative approaches, we got this one thread or this one poor guy trying to put out the fire by just loading data from the database or carrying buckets around of water to just pour it on the fire. And as you can imagine, a single guy, one bucket to carry, running back and forth, that can take a while. And yeah, potentially meanwhile, your server is on fire and the user went away because this just didn't scale.
So the fire got bigger, essentially. That's what is really boils down.
Yeah,
it's not off.
What you potentially could do in a traditional application or with the traditional approaches, you could just load more data at once. So go there and bulk fetch. In this case, the poor guy is now carrying, instead of one bucket, he carries two. But of course, this increases the weight he has got to carry, so he potentially won't be as fast as before running back and forth. And it's basically the same with your server, because once you increase the amount of load you put on it, so in terms of memory, you will run into other problems, because you might run out of memory if the load just increases. And yeah, in the end, you'll have the same scenario as before. Your server is heavily on the load, memory, you run out of memory, and everything's on fire back again.
So to summarize, yeah, that helps maybe my server, but it doesn't help the request in the front end because the request is still blocked, and I eventually run out of threads. So this isn't cool either. Well, is there perhaps anything else I could do?
Yeah, sure. I mean, what we've done so far, and pretty successfully actually, is we tried to scale up things a bit and delegate it to other threads. So in this case, that poor guy got help by a bunch of neighbors coming around, helping him turn out the fire. But still, there has to be someone coordinate all those guys, because you can't let them run around on their own. So there, in a threaded scenario, you gotta sync at some point to just deliver the data, coordinate it to the client. And of course, this adds overhead, and you still can run out of threads anyway and increase the load on your server.
So you're saying use futures, and then you have to synchronize it. So, but yeah, you know, that's quite complicated, and I'm running into callback hell, and it adds quite some sort of complexity. And you know how it works when you've got a bunch of people. You tell them to do something, and then they stop listening, and perhaps they never come back, or they come at the time where the fire wasn't actually there. So that isn't also cool.
Yeah, that's true. That's true. And if you ever dealt with the asynchronous chain and stuff, then you know that it's not really fun to work with. So what we've come up with is basically this other approach of reactive data access. And this is mainly about event-driven, stream-like data it's about emitting data in an event-driven stream-like fashion, so to speak, which reduces the memory footprint.
Oh, that sounds nice. So can you tell me more about that? How does it work? Do we have APIs for that?
Yeah, sure. There is this cool Project Reactor that gives you this amazing set of operations you can perform on the types they offer. They've got fluxes and monos, and you can really do a lot of things with that. But in the end, it boils down to the concept of reactive streams. So imagine you have this one guy there, let's call him a publisher, and he's got this new tool. He got a pump, a water pump, which is a huge improvement. And on the other side, there's this guy who's, let's call him subscriber, and he subscribes basically to the publisher saying, hey, I subscribe to you and now start giving me water. And then basically the stream of water or data just flows through the pipe from one to the other end as soon as it's available. So as soon as the pump starts pumping, the water gets to the other end.
Oh, that's an awesome concept. So you basically get a continuous stream of data as soon as it's available, and you reduce latency by that, and you get in continuity. But what if this poor guy in the front needs more water or less water? Can we do something about it?
Yeah, sure.
You know, if the fire gets low and I'm blasting water at full power, then eventually I'm wasting water.
Yeah,
you know?
You're drowning your own house, so you put out the fire and you get another problem. Yeah, sure, there is this concept of back pressure. So basically the subscriber can signal to the publisher, hey, give me more or less data at a time because I need it that way.
Oh, that's pretty cool, and it really sounds simple. What do I need to do in order to get reactive data access?
Pretty simple. You need Project Reactor in its 3.1 version. You need Spring.5 and Spring Data K or 2.0 as you want. And of course, what you need is a asynchronous non-blocking driver to support all that, and optionally Spring Boot 2 in its current M7 milestone. We're still waiting for GA. Hopefully it comes soon.
Cool, nice. So initially we talked about Redis, MongoDB, Cassandra, Couchbase, right?
Yeah.
So I think there's one missing that could be of interest. So yeah, right. What about relational databases? Because most people tend to run Oracles, Postgres, MySQL.
Yeah, I hear you. But sorry, folks, at this point, JDBC and JPA are still blocking APIs. And so there is currently no reactive support coming there.
But I'm a smart guy. I listened to the folks at Java 1, and they told me about asynchronous database access. Can you tell me perhaps more about that?
Pardon?
No. You can't.
No, I can't. Maybe you know something. You're the expert.
All right. Maybe you folks want to attend the next session at 4:20 here. So we will deep dive into reactive drivers and what they do, and then I can tell you a little bit more about asynchronous database access.
Cool. Okay.
So thanks for explaining, Christoph. That was really great. It really helped me.
Yeah,
and,
but still, you were cheating, actually, because you're the expert on reactive drivers.
No, I'm not. So what we can do now is, this is not only about reactive data access, but it's pretty much about also what Spring does for us and Spring Data supports. And Spring Data has support for reactive data access on multiple levels. So beginning with a template API, where you have quite lower level functionality that allows you to access the very functions of your data store. And then you step one step above with the repository support, where you abstract your data access through the repository abstraction. And that's also something which is supported in a reactive way. Though we have a slightly reduced feature set for our data stores, because it does not make sense to implement every single feature in a reactive way. But on the other hand, there are features like Tailable cursors, which makes a lot of sense to implement that in a reactive way. You could have that in an imperative way too, but you would be trapped again in something like a callback hell. And let's stop talking about just slides. Let's dive into the code. No, that's not that one, that's this one. Whoop, here we go. So what I would like to begin with is the MongoDB module. And perhaps if you already use today Spring Data MongoDB, you might be familiar with the Mongo template. And we introduced as a counterpart, as a reactive counterpart to the Mongo template, our reactive Mongo operations, which basically mirror all the methods that we provide on the imperative API. The difference here is that our methods do not simply return just a document or an object, but they return a reactive wrapper type. So Mono and Flux, these are Project Reactor types, and they will be your friends in a reactive world. And every single method returns a Mono and a Flux. There are methods that also accept Monos and Fluxes. So if you have a deferred value to insert, you can pass in that as a query argument or as an argument to insert. And the Spring Data infrastructure will take care of it to insert the data in a non-blocking way into MongoDB. And a very, very simple test, which is to insert the data and then start querying, could look like that way. I'm initiating a count on my MongoDB, printing out what the count will be. Then I'm adding 2 more elements, and again performing a count and printing that to verify what really happened in there. So let's give this test a spin. And besides that it's green, we see 2 more things. We see a system output of 4. So that was the initial count of records which was already available in my database. After inserting records and a few log lines, I will come back to that in a second, we see another output which is 6. And that shows me that my records were inserted. But what happens here? So reactive data access turns data access a little bit upside down because you give control over to the infrastructure and the platform to actually do the execution, to materialize the reactive sequence. So things are starting to happen on different threads. So that's what you already see here. We have a sequence of before convert and before save events. So that's all happening on the main thread, because that's obviously non-blocking. Then we are starting to talk to MongoDB. And you see then we have a switch in threads. So the main thread isn't anymore involved into that processing, but everything else happens on different threads. And that might be also the reason why some people figure reactive programming is hard, because stack traces differ quite a lot from imperative programming. And the root you are seeing is always some thread which isn't related in any kind to your code at all. But back to then. So after inserting the records, we receive after save events. That's something Spring Data MongoDB is emitting for you. And then we see, again, conversion and saving events and so on and so forth. So you see, there is a bit more involved than in a regular imperative data access, especially the thread switching thing, which might be something you have to get used to first. We have also support for RxJava types, in particular RxJava 2. Which I can illustrate the best with our repositories. So let's take a look on a plain reactive repository. So we introduced as counterparts to CRUD repository, the reactive CRUD repository. Again, you will find all the same methods you already might be familiar with here in the reactive CRUD repository. Again, returning reactive types, accepting reactive types, so you can basically stream in the data you receive directly into your database. Internally, it's translated into multiple database calls, but still, you can stream from one source in another, and that's a pretty neat thing, because it applies a very natural and very well-fitting notion of data access, because you're suddenly streaming data all over the place without actually the limitation of lists and collections that that imperative programming imposes on us. So let's have a look on the usage of the reactive repositories. We will find the very same methods over there, like in CROT repository. This bit of code is the counterpart to what I had previously in the reactive Mongo template. So inserting data, querying. First we will see 4, then we will see 6 as an output. And if I wouldn't have closed it, here we go. We see 6 and 4, and everything queried through the repositories API. What's really nice about repositories is that this is sort of a dynamic API in the sense that you are the ones who are creating the actual declaration, and we from the Spring Data side just pick it up and adopt to your code, which gives us the freedom to also use other reactive libraries, like the mentioned RxJava 2 library. We do not support RxJava 1 because that was already, by the time we implemented reactive support, something where the end of life was already known. And nowadays, the end of life is March next year or something like that. And we didn't want to come up with a new API that already bases on a dormant or no longer maintained reactive library. So we decided to switch from RxJava 1 to RxJava 2. And you are free to extend from RxJava 2 CROT repository, which basically is, again, a copy of the reactive CROT repository, this time using RxJava 2 types like single, like flowable. Flowable, by the way, is a backpressure-enabled interface in comparison to observable. So observable of RxJava 2 isn't backpressure-enabled. And there we do transparently adopt to your library, and you could even write an RxJava 1 based repository. We have all that code still inside of our Spring Data modules to do the adoption, but we do not ship any longer with RxJava 1 repositories. And yeah, it just works the same way the other one worked. Although the testing code is a bit more verbose than what we have with Project Reactor. So you see that's quite a bit of lines of code with a lot of additional assertions now here and then, but it's still producing the same behavior, the same performance, and allows us to just go on with the reactive library we like most. We have a similar example for Couchbase, for Cassandra. I'm not going to demo that. But I'm going to dive into Redis. So for Redis, we have a similar story, but only for the template API. Maybe some of you know that we have also we have Redis repository support, but that is very I/O intense, and to be very honest, nobody asked us to provide a reactive variant of that. So for the time being, we skipped that and only provide a reactive Redis operations API. Underneath, we use the Lettuce driver. It's, again, Netty-based. Redis is a fully blocking driver, so that's the reason why we can't use it. And just using thread pools isn't the real idea below reactive data access. It just moves the problem to a different spot, but still I haven't the problem solved. So therefore we decided to not integrate with Redis for reactive Redis operations. And what we can do, for instance, is accessing things like queue-like patterns, caching patterns. Maybe let's go to the caching example. So Redis itself is a key value store that allows me to store values and retrieve values from various data structures. Up to today, there is no Spring reactive cache, but with a few simple operators, I can build that on my own. So I take the value operations, attempt to retrieve a cache key. If it's not there, I use a switch if empty operator, retrieve the actual cache value, and save it in Redis with an expiry of 60 seconds, and then return just a value. So that's how many lines? 1, 2, 3, 4, 4-liner, and there I go with a reactive cache implementation. So let's run that, and I think my wait is here. Everything is delayed by 10 seconds, so that's the reason the log currently does not anything while I'm talking. And here we go, it's done. How long did it take? Roughly 10 seconds. And when I rerun that, the value is still in Redis present. The test finishes. No, demo gods hate me. So that should be, no, I did something actually wrong. I misunderstood my demo, sorry for that. So I'm flushing the cache afterwards. So what I actually wanted to show you, but I obviously did not, is we have two accesses, the initial access and the subsequent access. So the initial access takes the 10 seconds, and the subsequent access, which again triggers a Redis request, takes roughly 20 milliseconds or so, and then the value is served from the Redis cache itself. So that's quite nice thing, and if I would pay more attention that I'm flushing the database, I wouldn't run into the demo issue. Cool. So that's a basic overview that correlates more or less to the patterns we are used to imperative programming today. There are, however, other features that make a lot of sense to do them in a reactive way. Let me spin up my MongoDB here. So everybody of you that uses MongoDB may be familiar with the notion of collections within MongoDB. And there are a special type of collections within MongoDB which are called capped collections. And capped collections have a fixed size and compare the best to a ring buffer. So you write data onto it, and at some point it starts overwriting the data which is already present in that capped collection. And the nice thing about it is not that you can overwrite it, but that you can tail this particular collection, which means as soon as a new document arrives in MongoDB, you are able to receive that, or say it in a different way, the server is providing you with that new document, which is some sort of push style. And we adopted that functionality within Spring Data MongoDB. And all I need to do is either I use the operation template API, or I use it via the repository, and by just declaring a query method and placing the @tailable annotation, I'm saying, okay, please, when you spin up the query, please make it tailable, keep the cursor open, do not close the cursor once I exhaust all the data, but just let it go. And this fits really nice within WebFlux, so that's Spring's reactive web framework. And all I'm going to do is exposing that tailable cursor through server-sent events. So I have here a controller method that is exposed at /logins, returning a media type application stream. So I'm opting in for server-sent events, calling the repository method, which is tailable, and then it sends me all the data. So let's start it and see where we go. Let's curl it. P localhost 8080 logins. So here we go. So, and what do we see? That we get already a bunch of data. So that data was already available within MongoDB. And every now and then, you see a new line appearing in here. And the reason for that is I have a bit of initialization code, which asynchronously inserts data for me, so I don't need to insert that manually. And every 2 seconds, I think we are inserting data. Yeah, here we go. It's 2 seconds. The code looks horribly. Don't quote me on that. Still, you can find it online to see what's going on there. And as I said, every 2 seconds, I'm inserting the data. And by that, I'm receiving a constant stream of items which are available. And one other thing which fits also nicely into that is Redis PubSub. So we have already Redis PubSub for the imperative API, but with the reactive API, we can use it as simple as the Mongo part with our server-sent events and controllers. And that will be part of the upcoming Loveless release train. And everything I need to do is spinning up a Redis message listener container, subscribe to it, to a topic or a pattern, and then I basically go. So let's query that one. What was the API? It's events. Events/messages. And here I see, yeah, it's happening, but let's watch it from the beginning on, because that's not. Now it's stopped to being funny. Oop. Here we go. So it's starting to say, hey, hey, hey. So as you might imagine, I can see the same stuff also on with my regular Redis client, Redis CLI. P subscribe to star, and then I see again messages to that. I can also publish a message on my own, and you see it interleaved. And this is a really nice stateless communication pattern for streaming events that aren't persistent anywhere. MongoDB Tailable cursors are persistent, and you always get everything that's already available from the collection itself. So that's I think it for this session. If you want to know more about reactive data access and what really happens under the hood, stay here in this room until 4:20. I will explain how Redis, MongoDB, Cassandra, and Couchbase work under the hood, and how this really affects performance, and why you might see sometimes better performance, sometimes even worse performance. And other than that, thanks a lot for attending, and have a great spring one.